Hydrocarbons. In hydrocarbons, the next one is hydration. Hydration of alkenes and also hydration of alkynes. So what happens? Here hydration of alkenes. Hydration of alkenes are mainly three types. That is acid catalyzed hydration. Second one is oxymercuration, demercuration. Third one is hydroboration, oxidation. Hydration of alkenes. So that means here we are treated alkenes. Alkenes are converted into alcohols. In this hydration process, here alkenes are converted into alcohols. So first of all, now we are going to discuss that is acid catalyzed hydration. The first one is acid catalyzed hydration. So in this one, alkenes are treated with These are treated with, so that is water in the presence of acid. That is dilute acid. It is converted into alcohols. So in this reaction, the intermediate is carbocation. Here in this reaction, carbocation intermediate is formed. There may be possibility of rearrangement. So next one is, in this one what happens here? So let us discuss, let's just take one example, CH3, CH double bond, CH2. This is propene. Propene, it is treated with dilute H2SO4. Here it is converted into CH3, CHOH, CH3. This is isopropyl alcohol is formed. Now, so how this alkene is converted into alcohol? Now we are going to discuss that one. In this hydration, now we are going to discuss that is acid catalyzed hydration, that is alkenes are how alkenes are converted into alcohols. And also we are going to discuss that is what happens when alkyne is subjected to hydration. That we will discuss after this topic. So here alkenes, when it is treated with dilute acid, this is converted into alcohol. So the intermediate is carbocation. There may be possibility of rearrangement. ఇందులో ఏమైతుందంటే హైడ్రేషన్ అంటే వాటర్ యాడ్ చేయడము, ఆల్కిన్స్ను హైడ్రేషన్ చేస్తే హైడ్రేషన్ అనేది మూడు రకాలుగా చేయొచ్చు. ఒకటి ఆమ్ల సమక్షంలో, ఇంకొకటి ఆక్సిమెర్క్యురేషన్, డిమెర్క్యురేషన్, ఇంకొకటి హైడ్రోబోరేషన్, ఆక్సిడేషన్. ఇందులో యాసిడ్ క్యాటలైజ్డ్ హైడ్రేషన్లో ఇంటర్మీడియట్ ఆల్కిన్స్ తీసుకొని డైల్యూట్ యాసిడ్తో రియాక్షన్ జరపగా ఆల్కహాల్ వస్తుంది. ఇందులో ఇంటర్మీడియట్ కార్బోకటియాన్ ఇంటర్మీడియట్ ఎక్కడైతే ఫామ్ అవుతుందో అక్కడ మనకు పునరమరిక జరిగే అవకాశం ఉంది. సో ఇందులో ప్రోపీన్స్, దట్ ఈస్ ఐసోప్రోపైల్ ఆల్కహాల్ ఈస్ ఫార్మ్డ్. నౌ దీనిలో మెకానిజం, లెట్ us discuss that mechanism. So here first of all CH3, CH double bond CH2. So here that is H3O plus, addition of H3O plus. So that H3O, it is formed in H2O plus, H plus, that is H3O plus. So now this is converted into CH3, CH plus, and this is CH3. So this is the carbocation, this is a secondary carbocation is formed, This is a secondary carbocation. Isopropyl carbocation is formed. After the formation of this isopropyl carbocation, now it reacts with water molecule. That is what happens here, CH3, CH, OH, H, here it is plus, then this is CH3. So after the formation of this one, again water molecule abstract this H plus. Now this is converted into CH3, CHOH, this is CH3, this is isopropyl alcohol, this is isopropyl alcohol is formed. So this is what acidic catalyzed hydration. Let us discuss some more examples, some more examples. So in that one, so carbocation rearrangement takes place. So this main important is conversion of alkenes into alcohols, that is acidic catalyzed hydration, oxymercuration, demercuration, hydroboration, oxidation. This is acidic catalyzed hydration. Now, then in this reaction, so this is CH3, C, CH2, CH, double bond, CH2. If it is treated with dilute H2SO4, dilute H2SO4. What happens here? In this one, this is CH3, CH2, CHOH, this is CH3 is formed. So this is but1ene is converted into, this is 1, 2, 3, 4, this is butane, 2-ol is formed, butane, 2-ol is formed. Suppose if we take one more example, CH3, CCH3, CH, double bond CH2. This is 1, 2, 3, 4, this is 3-methyl, but1ene, It is treated with dilute H2SO4, So what happens? The product we will write after the completion of that mechanism. So again let us discuss that mechanism. This is CH3, CH3, CH, double bond CH2. Addition of H3O plus. So what happens here? This is CH3, CH3, this is CH plus, this is CH3. This is secondary carbocation. So in this one, the secondary carbocation undergoes rearrangement. Here 1,2 hydride shift takes place. 1,2 hydride shift takes place. 1,2 hydride shift. So what happens 1,2 hydride shift? CH3, CCH3, CH2, CH3. That means hydride means H minus is shifting. 1,2 hydride shift. 1, 2, 1,2 hydride shift. Here we get this is carbocation. This carbocation, this is tertiary carbocation. This tertiary carbocation, it is more stable when compared to in this reaction secondary carbocation. This tertiary carbocation is more stable. So in this example, here 1,2 hydride is shifting. So 1,2 hydride shift takes place, tertiary carbocation is formed, then addition of water, that is addition of water, and then minus H plus. So we get this is CH3, C, CH3, here it is OH, this is CH2, CH3. 1, 2, 3, 4. This is 2-methyl, butane, 2-ol, 2-methyl, butane, 2-ol. So here the product is CH3, C, CH3, here it is OH, this is CH2, this is CH3. So the structure, this is 2-methyl, butane, 2-ol, 2-methyl, butane, 2-ol. So when alkenes are treated with dilute H2SO4, this is converted into alcohols. In these alcohols, in the previous example, in the two examples, that is rearrangement is not taking place, but in this example rearrangement is taking place. So first of all, H3O plus, addition of H plus, then carbocation is formed. This carbocation, if 1,2 hydride is shifting takes place, what happens? This is secondary carbocation is converted into tertiary carbocation. Tertiary carbocation is more stable. So when compared to the secondary carbocation, therefore in this reaction 1,2 hydride is shifting takes place, and finally attacking of H2O and loss of H plus. So in this one, in these reactions, that is alkenes are converted into alcohols. And let us discuss one more example. In that example, that is 1,2 methyl shift takes place. So how 1,2 methyl shift takes place? As we discussed them. So now this is CH3, C, CH3, CH3, CH double bond CH2. Here this is 1, 2, 3, 4. This is 3, 3 dimethyl, 3, 3 dimethyl, but 1-ene, 3,3 dimethyl butane. If it is treated with H2SO4, again dilute H2SO4, what happens? So again let us discuss the mechanism. This is CH3 CH double bond CH2 plus addition of, that is H3O plus. H3O plus, what happens here? So in this one, that is CH3 CH3, this is CH3 plus. Protonation takes place here. Here if protonation takes place, we get a secondary carbocation. Suppose if protonation takes place here, we get a primary carbocation. When primary carbocation and secondary carbocation is more stable. Sir, any plus, we have to remember one point. If carbocation is formed, there may be possibility of rearrangement. In this one, what is happening here? 1,2 methyl shift. 1,2 methyl shift. So this methyl is shifting in the form of CH3 minus. So what we get here, this is CH3, CH3, this is CH3, this is carbocation. This is tertiary carbocation. This tertiary carbocation, this is more stable. Actually secondary carbocation is also stable, but here in this reaction, when compared to secondary carbocation, tertiary carbocation is more stable. Therefore 1,2 methyl shift takes place. Then again addition of water, then loss of H plus. So what we get here? So this is CH3, CH3, this is OH, this is CH3. This is the product. So everybody is expecting this product. Which product? That is CH3, CH, here it is OH, CH3. This is not formed. It is formed, but if it is formed, it is minor product. The major product is this product. The product is CH3, CH3. So COH, this is CH, this is CH3, this is CH3. So this is a major product. In this one, what is happening here? Carbocation shifting takes place. In the previous case, 1,2 hydride shift. In this case, 1,2 methyl shift. This is hydration. So in this hydration, let us discuss one more beautiful example, that is 1,2 bond shift. How 1,2 bond shifting takes place? Okay, 1,2 bond shift ela jarugutundi adi kuda discuss cheddam. Indulo 1,2 hydride shift, 1,2 methyl shift, 1,2 bond shift. Generally carbocations rearrangement takes place, whereas in carbanions and free radicals rearrangement does not takes place. So here we have this example. Here in this one. So here this is if we add H2, dilute H2SO4, dilute H2SO4, what happens? See here mechanism. In this mechanism, suppose if we take here one more methyl group, what happens in this methyl group? Here double bond, this is one mechanism. So H2SO4, H3O plus, addition of H3O plus, here carbocation is formed. Which carbocation? This carbocation. This is a tertiary carbocation. Tertiary carbocation is formed. This tertiary carbocation. So here 1,2 bond shift takes place. 1,2 bond shift. So if 1,2 bond shift takes place, what happens? 1,2 bond shift takes place. What happens? Here, this one, here 1,2 bond shift, here carbocation is formed. This is 6-membered. This is 6-membered. This is 6-membered. 6-membered carbocation is formed. In this 6-membered, let us take one thing. Here remove methyl group, here also methyl group. This one also methyl group. This methyl group. This is a, so what happens here? Carbocation is formed. This is which carbocation? This is a secondary carbocation. This is a secondary carbocation. In this secondary carbocation, what is happening here? In this one, 1,2 bond is shifting takes place. This is 5-membered is converted into 6-membered secondary carbocation. 6-membered secondary carbocation. So, ring expansion, what we get here, it is, this is methyl, this is carbocation, 6 membered with secondary carbocation. Again 1, 2 hydride shift takes place, 1, 2 hydride shift, 1, 2 hydride shift. So, what happens here, this is carbocation, tertiary and 6 membered, tertiary and 6 membered carbocation, then addition of H2O, then loss of H plus. So, we get this is a tertiary alcohol, this is a tertiary alcohol. So, once again here this is a beautiful example. So, here how many shifting takes place here? First of all 1, 2 bond shift, 1, 2 bond shift, after 1, 2 bond shift, then 1, 2 hydride shift, after 1, 2 hydride shift, that is addition of OH. Here we have 2 shifts. So, here actually ring stability 6 membered is more stable than 5 membered, 5 membered is more stable than 4 membered, 4 membered is more stable than 3 membered. So, here this is 5 membered ring, 5 membered ring is converted into 6 membered ring. This is a beautiful example. So, this alkene is treated with H3O plus, secondary carbocation is formed. The secondary carbocation 1, 2 bond shifting takes place. If 1, 2 bond shifting takes place, what happens? The ring is expanding. This is 5 membered ring, and 5 membered is converted into 6 membered, and it is also secondary carbocation. But here we have one more important, that is 1, 2 hydride shift. 1, 2 hydride shift, what happens? Secondary carbocation is converted into tertiary carbocation. After tertiary carbocation, then addition of H2O, loss of H plus, we get a tertiary alcohol. This is a more stable alcohol. Here in this one, what is happening here? So far we are discussed, that is alkenes are converted into alcohols. Alkenes are converted into alcohols. We have 3 methods, but the first method is completed, that is acidic catalyzed hydration. Acidic catalyzed hydration, carbocation is formed, carbocation maybe rearrangement takes place. The 3 rearrangements already we are discussed. One is 1, 2 hydride shift, 1, 2 methyl shift, 1, 2 bond shift. In this example 1, 2 bond shift, and then 1, 2 hydride shift also taking place. So, this is hydration. So, this is hydration. In this hydration, so in this hydration, that is 1, 2 alkenes are converted into alcohols, that is acidic catalyzed hydration. So, after acidic catalyzed hydration, now we are going to discuss second one, that is B reaction, oxymercuration and demercuration. It is very, very important for all entrance examination point of views, not only IIT and NEET and all entrance examination point of view. This is very, very important. So, what is happening here? First of all, alkenes are treated with mercuric acetate, HGO-AC taken twice, mercuric acetate, THF, mercuric acetate, and here in this one water. Mercuric acetate, this is oxymercuration, oxymercuration, then demercuration. In this demercuration, so we have to remove that mercury, therefore we are using reduction, that is NaBH4, sodium borohydride. So, alkenes are converted into alcohols, oxymercuration and demercuration. So, in the specialty of this reaction is, so carbocation intermediate is not formed, carbocation intermediate is not formed, Here this one rearrangement does not take place, rearrangement does not take place. Here this one follows Marconi-Cauchy rule. Okay, so take example. Let us discuss one example. CH3 double bond CH2 plus this is mercuric acetate HGO-AC taken twice, that is THF and H2O. Second one is, that is sodium borohydride. So, what we get here, this is CH3, CH3, CH, here it is OH, this is CH3. So let us discuss the mechanism. So what happens in this mechanism? This mercuric acetate HgOAc taken twice. This is nothing but CH3 C double bond O, that is HgO C double bond O CH3. This is a acetate molecule. This is acetate, mercuric acetate. This can also be represented like that, that is HgOAc. This is mercuric acetate. This mercuric acetate dissociates into CH3 COO minus plus Hg plus, that is O C double bond O CH3. Hg plus CO C double bond O CH3. So now, so what happens in this one? So this is CH3 CH double bond CH2 plus Hg plus OAc, Hg plus OAc. So this is converted into CH3 CH single bond CH2. This is HgOAc, here. This is cyclic intermediate is formed. In this cyclic intermediate is formed. In this one, then attacking of H2O molecule, This H2O molecule here always attacked the carbon where more substituted carbon is present. This is more substituted, this is less substituted. So here ring open takes place. So we get CH3, CH, CH2. This is HgOAc, this is OH, here it is plus. Then loss of H plus. So we get CH3, CH3, here it is OH, this is CH2, this is HgOAc. Then we have to remove this one. That is, therefore, this is we are adding sodium borohydride. In sodium borohydride, H minus attacks here, and this one elimination takes place. We get this is CH3, CH3, OH, this is CH3. This is, and one more point here. This is a this is anti-addition. This is a carbocation intermediate is not formed, rearrangement does not take place, and this follows Markovnikov rule. Here rearrangement is not taking place. Just here, this is alkene is converted into alcohols. Here in this one, this is an anti-addition, and one more point we have to add. This is a anti-addition. So this is alkene is converted into alcohols without rearrangement. The same compound, if it is subjected to acidic catalyzed hydration, so 1, 2 hydration takes place, here OH is formed. But this is oxymercuration and demercuration, so that is anti-addition, and this is Markovnikov's rule, and this rearrangement does not take place, carbocation intermediate is not formed. So this is conversion of alkenes into alcohols by oxymercuration, demercuration. So in this oxymercuration and demercuration, suppose instead of water, if you take alcohol, what happens? That is called alkoxymercuration and demercuration. Instead of this one, suppose CH3, CH double bond CH2. Suppose in this reaction, HgOAc taken twice, mercuric acetate, THF, and here we are adding, that is methyl alcohol CH3OH. In the previous case, we are added H2O. Okay, well H2O add just methyl alcohol. This is called alkoxymercuration, demercuration. Second step is sodium borohydride, that is NaBH4 in the presence of basic medium. So what happens here? So we get that is CH3, CH3, here it is OCH3, this is CH3 is formed. So if the same reaction, in the previous case we have discussed, that is HgOAc taken twice, THF, and here it is H2O. Second step is NaBH4. So what happens? We got this compound CH3, OH, here it is CH3. If we use water, alcohol is formed. If we use alcohol, we get ether. This method, this is a oxymercuration and demercuration. This is following Markovnikov's rule. Suppose if the same reaction, the first reaction, first acidic catalyzed hydration, what happens? Dilute H2SO4. In the dilute H2SO4, carbocation intermediate is formed, 1, 2 hydrate shift takes place. So what we got here, there is CH3, CH3, here it is OH, this is CH2, this is CH3. This is alcohol is formed. So here this is alcohol, this is alcohol, this is alcohol. This alcohol is formed by the rearrangement. These two alcohols, this is alcohol, this is ether. These two are formed without rearrangement. This is Markovnikov rule. This one also Markovnikov rule, but here carbocation intermediate is formed. In these two carbocation intermediates are not formed. This is a oxymercuration and demercuration. So after oxymercuration, demercuration, and next one, that is hydroboration oxidation. Hydroboration oxidation, this is nothing but HBO, hydroboration oxidation. Here this reaction is also used for the conversion of alkenes to alcohols. It is also an important reaction. Hydroboration oxidation, oxymercuration, demercuration, these two reactions are important. Alkenes, hydroboration, this we are treating with here, it is B2H6 in the presence of THF, B2H6. Hydroboration oxidation. In the second step, here we are adding H2O2 in the presence of NaOH, and here we are adding H2O. So this is hydroboration oxidation. Alkenes are converted into alcohols. Alkenes are converted into alcohols. Oxymercuration, demercuration, hydroboration oxidation, and acidic catalyzed hydration, all these are used for the conversion of alkenes into alcohols. In this one, we have one more point here. So this hydroboration oxidation, instead of H2O to NaOH and H2O, if we use acetic acid, suppose the first step is same, hydroboration is same, but in the second step, suppose if we use acetic acid, CH3COH, instead of H2O to NaOH and H2O, here we get alkanes, That means if we use H2O to NaOH, H2O, we get alcohols. Instead of this reagent, the first step is same, but the second step is different. If we use this one, we get alcohol. If we use this one, we get alkanes. So what happens? So here let us take one example. So main important points. First of all, what are the important points in this one? Important points. First point, carbocation intermediate is not formed. Carbocation intermediate is not formed. In the previous case also, carbocation intermediate is not formed. Then second one, rearrangement does not take place. There also rearrangement does not takes place. Next, third one, ఇక్కడ రీఅరేంజ్మెంట్ జరగదు, అక్కడ రీఅరేంజ్మెంట్ జరగదు, అక్కడ కార్బోకేటైన్ ఇంటర్మీడియట్ ఫామ్ కాలేదు, ఇక్కడ కూడా కార్బోకేటైన్ ఇంటర్మీడియట్ ఫామ్ కాలేదు. Next, then third one, so here this rearrangement does not takes place, and third one, that one follows Markovnikov's rule, this one follows anti-Markovnikov's rule, this one follows anti-Markovnikov rule. That is a Markovnikov's rule, this is an anti-Markovnikov rule, and that is an anti-addition, this is a syn addition. This is a syn addition. Okay, so what happens? See here, okay, example, CH3 CH double bond CH2. It is treated with B2H6 THF, tetrahydrofuran solvent. The second one is, that is H2O2 in the presence of NaOH, and here it is H2O. Here we get alcohol CH3 CH CH3 CH2 CH2, here it is OH. Here we are added OH at terminal carbon, that means Markovnikov or anti-Markovnikov. This is a anti-Markovnikov rule. In the previous case, Markovnikov rule. So now let us discuss the mechanism. So how this alcohol is formed? So first of all, so mechanism, what is happening here? So B2H6 is nothing but, this is nothing but BH3. So here in this one, first of all, CH3 CH double bond CH2. Here H and BH2, H and BH2. Here one point, H is always added to more hindered carbon or more substituted carbon or more hindered carbon, and where is BH2 is added to less hindered carbon where double bond is present. ఇది more hindered carbon దగ్గర అటాక్ అవుతుంది, ఇది less hindered carbon దగ్గర అటాక్ అవుతుంది. So this is CH3, CH3, this is converted into what? CH2, single bond, CH2, this is BH2 is formed. Actually this is proceeds through transition state. So what are the transition state? CH3, CH3, this is CH2, so this is H, this is BH2, yeah, this is transition state, this is having carbocation character, this is having negative charge. This is a more stable transition state, this is a more stable transition state. And we have one more possibility. So what is that possibility? CH3, CH2. So suppose if BH2 is attacked at this carbon, what happens? So this is what happens here. We get this is partial positive charge, this is carbocation character, this is negative charge, this is a primary carbocation character, this is secondary carbocation character. Therefore this is a more stable transition state, this is less stable transition state. This is a less stable transition state. Why? Because the transition state, this carbon is having primary carbocation character, therefore this is less stable. This is the secondary carbocation character, it is more stable. So this one proceeds through more stable transition state. Therefore H is added to the double bonded carbon where steric hindrance is present. BH2 is added to the double bonded carbon where the steric hindrance is less. So this is and one more point, this is a syn addition. Why it is called syn addition? H and BH2 is both are added to the double bonded carbon atom same side, therefore this is called syn addition. In the previous case, that is Marconi, that is oxymercuration, demercuration, that is a anti addition. Now let us continue that this one. So that is this is formed which one? This is CH3, CH2, this is BH2. Again we have so many molecules in the solution. So next one more molecule CH3, CH double bond CH2. Again addition takes place. This is BH2, H is added to this carbon and BH total molecule is added to this carbon. So we get what? This is CH3, CH2 taken twice BH, Again this one reacts with one more molecule. Why? Because already here we have two hydrogens, one hydrogen is already added to one more molecule, we have one more hydrogen, therefore one more, it reacts with one more molecule of alkene, CH3, CH double bond CH2. This H is added to this carbon, the total part is added to the terminal carbon. This H is added to this carbon and the total part is added to this carbon. So we get that is CH3, CH2 taken thrice B. This is nothing but trialkyl borane. Now this trialkyl borane, now I am representing like this R3B. This group is I am considering R. పెద్ద గ్రూప్ దీన్ని మైకానిజం రాయడంలో చాలా ఇబ్బంది అవుతుంది కాబట్టి ఈ గ్రూప్ మొత్తం R గా కన్సిడర్ చేస్తాను. R ఈజ్ నథింగ్ బట్ హియర్ CH3, CH2, CH. This is R. This is R3B. So only one step completed. This is hydroboration completed. So now we are going to discuss that is oxidation, hydroboration oxidation. So now, so what happens in this one? So that is hydroboration completed. Next one is oxidation. That is trialkyl borane R3B. So this we can write like this B, R, and R. Actually here we are taking hydrogen peroxide HOOH. Here it is treated with OH minus. So this hydrogen peroxide, it is having acidic nature. This is a base. This one abstract this H plus. This is converted into HOO minus plus H2O. Now the formed this one, the formed this one, here it attacks at boron, here it attacks, that is OOH minus. Now it attacks this boron. So what we get here, this is B, R, R and it R, this is OOH, this is minus. So what happened next step? This alkyl group is migrated from boron to oxygen, then elimination takes place. So we get Br and it is OR, this is R. Again same phenomenon takes place, HOO minus, it attacks here. So we get this is Br, this is R, this is OR. Again, so what we, this is here OOH, here it is minus. Next again alkyl group is migrated, then elimination of this one. So this is B, OR, OR and this is R. Again one more HOO minus, here it attacks, then this is B, OR and this is OR and this is here this is R, this is OOH, this is minus. Next one, again alkyl group is migrated from boron to oxygen, then elimination of OH. So we get this is B, OR, this is OR and this is OR, this is plus OH minus, OH minus. So after this one, the next step, that is B, this is OR, right, this is OR. After this step, next this is BOR taken thrice, then OH minus addition takes place, then we get that is ROH, that means alcohol is formed. Alcohol is formed. This is according to anti-Markovnikov's rule. So see, in this process, important point here, suppose here in this process the main important point is, so this hydrogen, one hydrogen, this is B2H6, HBH3, this is BH2. This hydrogen, one hydrogen is added to one carbon, that is hydrogen from BH3 and oxygen from H2O2 and hydrogen from NaOH. Okay, example తీసుకుందాం. ఇదేంటంటే CH3, CH double bond CH2. In this one, for example, B2D6 THF. Second step is H2O2 OH minus and here it is H2O. This here OH2O2 is nothing but normal H2O2. ఇది normal H2O2 కాదు, ఇది different. ఇది ఏం చేస్తున్నాం, O18 ఆక్సిజన్ లేబులింగ్ చేస్తున్నాం. అప్పుడు మనకి ఏం ఫామ్ అవుతుందంటే CH3, CH3, here this is deuterium. So where it is coming? That is coming from B2H6 and here this is CH2OH, this is O18. And next, suppose if we take the same example, if we take B2H6 in the presence of THF, second one is H2O2 O18 and here it is OD minus. What happens? Here we get this is CH3, CCH3, this is CH3, CHD and this is CH2 OD and this is 18. OD and 18. This is not D, this is H2. Hydrogen is coming from H2, B2H6. So this hydrogen is added to BH2. This hydrogen is added to CH2. This is hydroboration oxidation. So this hydroboration, oxidation, oxymercuration and demercuration. So acidic catalyzed hydration, these three reactions are important for conversion of alkenes to alcohols. Okay, this is alkenes to alcohols completed. So after this one, sir, what happens when hydration, when it is subjected to alkynes? Alkynes को hydration చేస్తే ఏమవుతుంది? Alkenes కు చూసాం, alkenes ఏమయ్యాయి, alcohols గా మారాయి. Hydration of alkynes. So here alkynes, when it is subjected to hydration, here alkynes are converted into carbonyl compounds. Alkynes are converted into carbonyl compounds. So here we have two methods. One is that is mercuric mercuric catalyzed, mercuric ion catalyzed, mercuric ion catalyzed hydration, mercuric ion catalyzed hydration. Second one is hydroboration, hydroboration and oxidation, hydroboration, oxidation. Mercuric ion catalyzed hydration, second one is hydroboration, oxidation. So, first of all, this is mercuric ion catalyzed, mercuric ion catalyzed hydration, mercuric ion catalyzed hydration. Sir, mercuric ion catalyzed hydration, what happens mercuric ion catalyzed hydration? So, here see here, this is alkyne, alkyne. Here alkynes are treated with, alkynes are treated with, that is dilute H2SO4 in the presence of HgSO4, that is Hg plus 2 acts as a catalyst, Hg plus 2 acts as a catalyst. Here what happens here, this is carbonyl compounds are formed, that is aldehydes or ketones are formed. So, let us take one example, this is CH triple bond CH, this is acetylene, this is acetylene. Acetylene, it is treated with dilute H2SO4 means H2O, dilute H2SO4 means H2SO4 contains water, this is dilute H2SO4, and here in the presence of HgSO4, that is H plus. So, what we get, this is CH3 C double bond OH, this is acetaldehyde is formed. What happens here? Acetaldehyde is formed. Now, see at the mechanism. So, what happens in this one? So, CH mechanism in this one, that is CH triple bond CH, that is Hg plus 2. So, this one forms CH double bond CH, here this is Hg plus 2. So, now this is addition of H2O, addition of H2O, it attacks here and ring open takes place. This is CH2 OH, H, here it is plus, then this is CH, this is double bond, sorry, it's not CH2, this is CH, double bond CH, and here it is Hg plus 2. So, this Hg plus 2, this is converted into Hg plus 1, next loss of H plus. So, this is CH, OH, double bond CH, this is Hg plus, this is tautomerism, here this is C double bond OH, this is converted into CH2, this is Hg plus. So, after this one, then this bond undergoes cleavage, here we have so many water molecules, now this one abstract this H plus, so we get this is Hc, here it is OH, this is double bond CH2, this is enol form, this is enol form, again 1,3 proton shift, again 1,3 proton shift, this is 1,3 proton shift. 1,3 proton shift is nothing but tautomer, that is enols are less stable. So, now this proton is migrated from oxygen to carbon and this bond is migrated. So, what we get, this is Hc double bond O, this is CH3, acetaldehyde is formed. Acetylene is converted into acetaldehyde, acetylene is converted into acetaldehyde. In this reaction also rearrangement does not take place. So, let us discuss some more examples in mercuric ion catalyzed hydration. So, first of all, this acetylene is treated with water in the presence of H2SO4 and HgSO4, that is converted into acetaldehyde. This is the mechanism. So, right after this one, now some more examples regarding this hydration reaction. Hydration reaction, see CH3 C triple bond CH plus H2O in the presence of HgSO4 and H2SO4. Here the product is, first of all, intermediate is, that is CH3COH, CH3COH, double bond CH2, this is nothing but so alcohol, vinyl alcohol, enol, this is a which form? Enol form. This is a enol form. This is double bond en and ol, this is a enol form. Enol form is less stable. What happens here? Tautomerism takes place. That is 1,3 proton shift. 1,3 proton shift. What we get? This is CH3 C double bond O CH3. This is acetone is formed. This is acetone is formed. So, here in this reaction, if you observe the mechanism, again CH3 C triple bond CH, C triple bond CH, then Hg plus 2, then Hg plus 2. this is CH3 C triple bond, this is C double bond CH, and this is Hg+2. This is Hg+2. Attacking of H2O. H2 attacks this carbon. Why? Because this carbon it is having carbocation character. So now this ring open takes place. This is CH3 C, then loss of H plus. We get this is OH, and here this is CH, this is Hg plus. So continuation steps, that is we get that is CH3 C double bond O CH3. This is acetone is formed. Acetone is formed. Suppose in this one, suppose NO2 CH2 C triple bond CH is present. Let us consider. So here it is treated with H2O in the presence of HgSO4 and H2SO4. Here this is NO2 is a electron withdrawing group. This is electron withdrawing group. So this withdraws electrons. Therefore, this bond these pi electrons are migrated toward this side. So this is having positive charge. This is having negative charge. So what we get, this is NO2 and here it is CH2. This is CH2. This is what happens. This is CH double bond CHOH. CHOH. This is again which form? This is a enol form. This is a enol form. Again 1,3 proton shift. 1,3 proton shift. 1,3 proton shift is nothing but that is called tautomerism. So we get NO2. This is CH2. This is CH2 C double bond OH. So this is alkynes are converted into aldehydes, or alkynes are also converted into ketones. Alkynes are converted into aldehydes and alkynes are also converted into ketones. This is propine, that is acetone. Din tarvata next hydroboration oxidation. Hydroboration oxidation. The second one is that is B, hydroboration oxidation. Hydroboration oxidation. So in hydroboration oxidation, what happens? Hydroboration oxidation. In hydroboration oxidation, that is alkyne, it is treated with B2H6 THF, B2H6 THF and H2O2 OH minus and H2O. Here again we get what? Carbonyl compound. Here again we get carbonyl compound. Same here, this one hydroboration oxidation, this one follows anti-Markovnikov's rule. Markovnikov's rule, anti-Markovnikov's rule. A rearrangement does not take place. A rearrangement does not take place. Rearrangement does not takes place. And here this is a syn addition. This is a syn addition. And here, so this one follows anti-Markovnikov's rule. This is a carbonyl compound is formed. Let us take one example, CH3 C triple bond CH. So in this reaction, one more important point, not only B2H6, we can use that is SiA2BH. SiA2BH. This Si2ABH is nothing but DC-amyl borane. DC-amyl borane or diisoamyl borane. So isoamyl means CH3, CH, CH3, CH, CH3, C, how many? 1, 2, 3, 4, 5. This is a isoamyl. This is a DC-amyl, diisoamyl borane. That means we can use R2BH also, R2BH, dialkyl borane. This is a dialkyl borane. When compared to BTH6, this is a best reagent for the conversion of alkynes to carbonyl compounds. And next here, not only this one, we can also use 9-BBN, 9-boro bicyclononane. This is 9-BBN is nothing but 9-boro bicyclo 3.3.1, 3.3.1. This is nonane is formed, nonane. So this can also be used DC-amyl borane or 9-BBN or B2H6. So here what happens? Suppose if we take that is B2H6, that is a B2H6, B2H6 THF, this is the first point, this is the first stage, and the second stage is H2O2 and here it is OH minus and H2O2, H2O. So what happens here in this one? So this is converted into CH3, CH, double bond, CH, here it is OH, this is again enol form, this is again enol form. Enol form is less stable, this is converted into 1,3 proton shift, 1,3 proton shift. Here what happens, this is CH3, CH2, C double bond OH, this is aldehyde is formed, aldehyde is formed. Hydroboration oxidation, alkyne when it is treated with B2H6, THF, H2O2, OH minus, H2O carbonyl compound is formed. This is B2H6 used, or otherwise dialkyl borane, R2BH is also used, SiA2BH, that is, or otherwise 9-BBN, 9-boro-bicyclo-nonane. The best reagent is Si2ABH. In this one we can, one more point here, from this one we can also prepare alkenes. So that is B2H6, this is B2H6 in the presence of THF, the first stage is same, the second one is H2O2 OH minus and H2O. So instead of that one, if you use acetic acid CH3 COOH, we get that is alkenes are formed, alkene, this is cis alkenes are formed, this is CH3 CH3H. That means hydroboration oxidation, hydroboration oxidation, hydration of alkynes. So from hydration of alkynes, so what we get, that is carbonyl compounds. The final conclusion of all these hydroboration, oxidation and hydration reactions, in hydration reactions, the final conclusion is alkenes can be converted into alcohols, and alkenes can also be converted into alkanes, and alkynes can be converted into carbonyl compounds, alkynes can also be converted into carbonyl compounds. This is what, this is nothing but this is hydration of alkenes and alkynes completed. The next one is, that is alkynes. Next one is alkynes. In alkynes, that is C triple bond R, C triple bond Cr, this is alkyne, and the carbon hybridization is sp, and C triple bond C, bond length is 1.20 angstroms, and here the bond angle is 180 degrees. In the generally, if you take this is in this one, this is not formed. Why? Because this is sp hybridization, this is also sp hybridization, 180 degrees angle, 180 degrees angle, it is not possible in 6-membered ring. So generally it is possible in 9-membered and greater than 9-membered, 8-membered is also some possible, but less than 8-membered triple bond is not formed in ring structure. రింగులో ఒకవేళ 8 కార్బన్ల కంటే ఎక్కువగా ఉన్నప్పుడు మాత్రమే ట్రిపుల్ బాండ్ పాసిబుల్ అవుతుంది, కానీ 6 కార్బన్లు 7 కార్బన్లు ఉన్నప్పుడు ట్రిపుల్ బాండ్ అనేది పాసిబుల్ కాదు. ఎందుకంటే హైబ్రిడైజేషన్ sp హైబ్రిడైజేషన్ అంటే బాండ్ యాంగిల్ 180 degrees ఉంటుంది. Now, so here in this one, so that is alkynes preparation methods of preparations of alkynes, that is methods of preparations of alkynes, So first one is from dihalogenated compounds. డైహాలోజినేటెడ్ కాంపౌండ్స్ నుంచి మనం ఏమి తయారు చేయాలి, ఆల్కైన్స్ను తయారు చేయాలి. డైహాలోజినేటెడ్ కాంపౌండ్స్ ఆర్ టూ టైప్స్. Geminal dihalides. Second one is vicinal dihalides. Geminal dihalides and vicinal dihalides means if two halogens are present at the same carbon atom, then it is called geminal. Gem means pair. అగర్ ఒకే కార్బన్ మీద 2 హాలోజన్లు ఉంటే దాన్ని జెమినల్ అంటారు. సో జెమినల్ అంటే ఎగ్జాంపుల్ CH3 CH, here Br, this is Br, this is a geminal dihalides. Vicinal dihalides అంటే if two halogens are present on adjacent carbon atom, CH3 CH Br CH2 Br, this is vicinal. పక్క కార్బన్ పైన ఉంటే దాన్ని విసినల్ అంటారు, ఒకే కార్బన్ ఉంటే దాన్ని జెమినల్ అంటారు. జెమినల్ ఈజ్ నథింగ్ బట్ దిస్ ఇస్ నథింగ్ బట్ 1,1. దిస్ ఇస్ విసినల్ ఈజ్ నథింగ్ బట్ 1,2. జెమినల్ డైహాలైడ్స్ను విసినల్ డైహాలైడ్స్ను ఉపయోగించి మనము ఆల్కైన్స్ను ప్రిపేర్ చేయొచ్చు. ఎలా అంటే మనము చాలా స్ట్రాంగ్ బేస్ వీ హ్యావ్ టు యూజ్ వెరీ స్ట్రాంగ్ బేస్ యూజ్ చేస్తే మనకేం ఫామ్ అవుతాయి, ఆల్కైన్స్ ఫామ్ అవుతాయి. ఎలా అంటే చూడండి, ఇక్కడ ఆల్కైన్స్ తీసుకున్నప్పుడు సింపుల్ ఎగ్జాంపుల్ CH3 CHBr, దిస్ ఇస్ CHBr 1 2 3, this is 1,2 dibromo, 1,2 dibromo propane. When it is treated with NaNH2, here we are using excess. What happens? Here we get CH3 C triple bond C, this is Na, C triple bond C, Na again on acidification, that is in neutral medium. So what we get, this is we get CH3 C triple bond CH. So in this reaction what is happening here? HBr is eliminated, one more HBr is eliminated, that is nothing but double dehydrohallucination. This is called double dehydrohallucination. ఇక్కడ మీకు ఒక డౌట్ రావచ్చు, సరే NaNH2 కాకుండా వేరే బేస్ NaNH2 యూజ్ చేస్తుంటే మనం లో టెంపరేచర్ యూజ్ చేయొచ్చు. ఒకవేళ ఆల్కహాలిక్ KOH యూజ్ చేసుకుంటే డబుల్ డిహైడ్రోహాలోజినేషన్ చేయడం కష్టంగా ఉంటుంది. ఆల్కహాలిక్ KOH యూజ్ చేసుకుంటే హై టెంపరేచర్ ఒకవేళ యూజ్ చేస్తే హై టెంపరేచర్ 200-300 డిగ్రీ సెల్సియస్ యూజ్ చేస్తే ఆల్కైన్స్ ఫామ్ అవుతాయి. కానీ ఆల్కహాలిక్ KOH యూజ్ చేస్తే దాన్ని మనం లో టెంపరేచర్ దగ్గర మనం ఆల్కైన్స్ ప్రిపేర్ చేయలేము. ఇక్కడ మెకానిజం అబ్జర్వ్ చేస్తే దిస్ ఇస్ అగైన్ విచ్ మెకానిజం, దిస్ ఇస్ E2 మెకానిజం. CH3 CH, this is Br, this is CH2 Br. Here we are treating with NaNH2, that is NH2 minus, strong base. In this strong base NaNH2 minus. So here this is with respect to this halogen, this is alpha, this is beta, this is a beta carbon. With respect to this one halogen, this is alpha, this is beta. So where it is abstracting? So this is abstracting this CH2, this is alpha, this is beta. Sir, why it is not abstracted? This one also abstracted, but in the first step this one abstract this. Why? Because this is Br minus I effect. So here this carbon hydrogen is more polarity when compared to this one. Why? Because this is having plus inductive effect group and this is minus. This is here in these two carbons Br is same. Br in this one Br is same.